Hi there, my name is Joseph Bogar. I'm the Executive Director of the Save Our Wild Salmon Coalition. We're a group of organizations that have been working for over 30 years to protect and restore healthy, self-sustaining, and abundant populations of salmon and steelhead in the basin that was once the most productive salmon landscape on the planet, the Columbia Snake System. Save Our Wild Salmon is a coalition of 40 plus groups that include conservationists, fishing folks, clean energy and orca advocates and others working together to restore salmon and their habitats in the Columbia Basin. And one of the areas of particular focus is restoring the lower Snake River as an essential cornerstone for protecting and restoring Snake River populations and all the benefits they bring to our region. Tonight we have the honor and pleasure of conversation led by three preeminent scientists from the Pacific Northwest: Helen Neville, who's the senior scientist at Trout Unlimited today; Rick Williams, who has been working for decades on salmon research in various capacities; and Jim Martin, who is a scientist and manager who worked for the state of Oregon under Governor Kitzhaber back in the 90s and has long been viewed as an expert on these issues. So I want to welcome you all for watching tonight. We're going to spend an evening looking at where the science is today, in particular focused on meeting the needs of the four endangered populations of salmon and steelhead in the Snake River. The science is really in. There's not much room for debate. It's time to restore that river, or we will come ever closer to losing these fish and the benefits they bring to our region forever. So thanks for being here this evening. Let's get started. Helen, thanks for being here, and I'll let you start off with the presentation. We'll go from there.
So as Joseph said, we thought it would be helpful to just give a brief overview. It's about 20 slides, shouldn't be more than 15, 20 minutes, to just get everybody grounded on what we think are the most salient and timely and important points about this system and where we are today, to just ground our discussion in a little bit. So really, I think it's important to know that we all feel as scientists, and many scientists throughout the Pacific Northwest really have been emphasizing of late that restoring the Snake River migration corridor is truly the linchpin for restoring salmon and steelhead, and we'll walk through why. So just to get you oriented, for those of you who may not be as familiar with this basin, this is a map of the Columbia River Basin as a whole. You can see this is the dark gray is the Snake River Basin. The areas in red are historic habitat that's behind impassable dams like the Hells Canyon and Vorshak Dam. This lower area was traditionally or historically more fall Chinook areas. So what we're talking about today is this area in blue here. And as Joseph mentioned, it's truly important to recognize that the Columbia was historically the most productive Chinook habitat in the world. And within that, the snake has outsized contribution. It represents about 19% of the flow, but historically it contributed 55% of the summer steelhead and 45 and 39% of summer Chinook and spring Chinook. So it really was a Chinook factory. This is the status for wild Snake River spring and summer Chinook today. It's just one example. So you can see the abundance of adults here on the y-axis, and along the x-axis are the times from the sort of middle of dam construction era to today. It's important to note down here at the bottom that previous to the 1960s, there was a very intensive, large commercial harvest on these fish, canneries and the whole 9 yards. It was a really large impact back in that era, but that has largely been managed and is carefully regulated today. The dams were begun earlier than this graph shows. So there were 2 Columbia River dams already completed here, and then the Dalles and the John Day were completed throughout this period, but it was really these 4, the Ice Harbor, Lower Monumental, Little Goose, and Lower Granite, that you can see coincide directly with this major decline in Chinook salmon. And so we move into the 1992 to 1997, 8 era, or 1999, when the fish were just at really terribly low levels as they are today, and were listed under the Endangered Species Act, with the stocks that are listed under the ESA at the bottom there. So one other thing that I think is important context is that it's important to understand that the Snake River dams have numerous impacts. People often think about the impacts of the fish as they go to the dam and pass over the actual structure. but the impacts are much broader and cumulative. They inundate, the Snake River dams in particular, inundate 140 miles of spawning and rearing habitat under hot, slow reservoirs. So we not only lose that spawning and rearing habitat, which greatly impacts production of fish, but these hot, slow reservoirs really increase the amount of energy that the outmigrants have to use, and so that decreases their condition. It's simplified habitat, so there's less cover and food, and they increase the dam and reservoir related predation, especially from introduced exotics that are really thriving in this sort of not natural environment. So overall, those factors dramatically increase juvenile mortality, and that we can measure. So it's known that about 50% of the juveniles are killed as they move out of the system, or die as they move out of the system through the hydropassage. And another factor is that they have delayed migration. So the slow reservoirs and the accumulation of many reservoirs throughout the system delays their migration sometimes up to 10 times what the historic migration was, which used to be very rapid. So that means that they have a mismatch between their physiological process of smoltification and getting ready to enter saltwater and the timing that they enter. Then they enter the ocean, which is kind of a big black box in a lot of ways. We know there is obviously natural mortality in the ocean, but there's this other factor called latent mortality, which is additional mortality for the fish that survive the hydropassage. Many of them still die, and it's directly attributed to their passage experience. So it's, this is a hard thing to measure, but ranges up to about 67% in some estimates. So it can be highly significant on the remaining 50% of the fish that enter the ocean. Up to a good 2/3 of them almost can suffer mortality due to their experience in the hydropassage. Then they come back in the Columbia and they return to spawn. So there's additional adult mortality on return. That's not as significant as these other factors in most years, but in some of the hot temperature years that we've endured in recent years, it can be very significant mortality. And overall, those that survive are still, under more stress under the temperatures that they've had to migrate and the stress of navigating the dams. So because of this cumulative impact and the impacts throughout the life cycle, there's a really important management metric that many of you may have heard about, but it's kind of grounding for understanding what the goals are in the system. It's called the smolt to adult return ratio. And it's basically the number of adults that return to the uppermost dam where it's measured, and that can vary, over the number of smolts that outmigrated and contributed to this adult class. And it's important because it's the only metric that incorporates most of the overall mortality and cumulative impacts of the dam, because it covers most of the life cycle. And it's essential that this metric is increased to improve the productivity of these salmon populations. And we can talk about in the discussion a little bit to see the benefits of a lot of the habitat restoration to date and the actions that we've taken to date. We know we need at least 2% SAR, so 2 spawners returning out of every 100 smolts to sustain populations in the Snake River. And by sustain, that means just ensuring that they are large enough not to go extinct, so they can persist without a high risk of extinction. But we need at least 4% SARs, or 4 out of every 100 to return, and even more to rebuild these populations to robust and potentially harvestable populations. But the problem is currently we're not even getting 1. So this is a blow up of that map of the Snake River. So you can see we're coming in here at the Snake River dams. If we look at the lower populations like the John Day that only have to pass 3 dams on their migration, you can see that their SARs returning to Bonneville Dam is where they're measured is 3.5 on average of late. So that is a sustainable and growing trajectory for them. The Yakima up here passes 4 dams, and their SARs recently have been averaging about 2.4%. But by the time we get up to the Snake River, the SARs measured back to Bonneville Dam are 0.9, and once they get all the way up to Lower Granite Dam at the top dam, our returns are 0.8%, and that is a indicator of decline. Those populations are declining and on a trajectory down, where if nothing is done to dramatically change this, they will go extinct. You can look at this at a different way, and this includes steelhead. These averages are a little older than the ones I showed you before, but you can see that the more dams the salmon have to pass, the fewer fish return to spawn. So again, here's that smolt to adult ratio. The 2% goal is the sort of minimum, 4% goal to start rebuilding. Green are summer steelhead, and the orange is spring summer Chinook salmon. So you can see the Deschutes again with 2 dams, they average well over 4%. For steelhead, and then the John Day populations here for Chinook and steelhead. And as you move up to the Snake River, there's this almost linear decline. And our populations are well below these numbers that are needed to even sustain them and ensure they won't go extinct, much less to rebuild them. And it's important to recognize that these don't represent just spatial patterns, but also temporal patterns. So we have seen not only that they vary geographically, but that they have changed over time. So in the mid to late 1960s, when there were 5 dams in place, so the 4 Columbia dams and 1 of the Snake dams was in place, but not the other 3, the SARs for Chinook, spring summer Chinook ranged from 3.5 up to 6.5%. So they had huge potential, huge production potential, and were very robust. But we've seen, as the dams went in, there was a steeper decline in the snake populations compared to the lower populations to the dams. And today the Chinook salmon up here survive about 1/4 as well as those in the John Day, for instance. And we have, hatcheries are another complicated situation here that are important to talk about, I think, and we can discuss this a little bit more. But just for information, we have about 30 million hatchery smolts released in this basin annually, but they fare even more poorly. About 80% of most runs here are of hatchery origins. And these are really important because they're essential. They're part of the mitigation for the tribal rights to harvest. So that's an important component of the system with the dams in place. But they generally have lower survival. So this is another one of these SAR graphs here on the right for, in this case, steelhead. You can see the wild in green and the hatchery fish in brown. And you can just see that the smolt to adult returns are much lower for the brown hatchery fish than they are for the wild fish, because wild fish generally have higher survival because they have better fitness, and hatchery fish have reduced fitness compared to wild fish. They're just not the same beast. Another important note is that it is wild fish that must be recovered under the ESA, but you can see in this case that both need a restored migratory corridor. In the situation we're in today, we're not getting enough returns of either, and so even the hatcheries aren't being sustained. So what are the management changes since the ESA listings? We've retrofitted dams, modified flows and spill, built complexes of hatcheries, restricted harvests, added barging and other technical fixes, undergone massive predator control, written recovery plans, dozens and dozens of status reports and hundreds of scientific studies, restored spawning and rearing habitats. We've spent 17 billion and counting invested in trying to recover these fish, but they are still on a path to extinction. And we're seeing these identical declines even in the best of habitats up here. So, the Middle Fork, we can talk about a little bit more later as well. The Middle Fork Salmon River is a really important contrast because it is in the best of the best habitat here. It's largely in wilderness, excellent habitat, no hatcheries, low harvest. These fish, the spring summer Chinook here, have been recorded to have among the highest productivity observed for spring summer Chinook salmon, meaning that they can generate fish when given a chance, but their declines exactly mirror the declines of the Snake River because the fish are not able to return to continue the spawning and sustain those populations. I know this is busy and you don't need to look at the graphics within it, but this is from a really jarring report that came out this summer by the Nez Perce tribe, where they were evaluating how many of these populations have now hit what they're calling the quasi-extinction threshold. This is a threshold that is indicating a severe risk of extinction and kind of entering uncharted territories with how to predict and manage what's going on with these fish. The graphics here are just showing the different populations in the Snake River, and collectively, currently, 42% of our spring summer Chinook are at or below this quasi-extinction threshold, which is 50 adult spawners. And their modeling predicts that by 2025, 77% of our populations will be there. And so without drastic action to change this trajectory, we are heading towards a potential extinction. And I know something that is dear to many of you, particularly who are coming from the West Coast. This impacts all of us, and it also impacts the southern resident orca. You can see down here at the bottom left this quote from the Orca Recovery Plan by NOAA in 2008, that perhaps the single greatest change in food availability for resident killer whales since the late 1800s has been the decline of salmon in the Columbia River Basin. And remember what we talked about earlier, that the snake has an outsized contribution, has outsized importance in terms of the abundance of fish that are generated in the Columbia. And it's so there's a numbers issue. We need these fish in their abundances to help bolster these orca populations. There's also a timing issue in that these spring fish are hitting the mouth of the Columbia in their returns at a critical time in the late winter and the early spring, when the orca are coming there to feed. The fish are big and lipid rich, fat rich, as they're just entering the Columbia. And so that's a critical period of food needs for these orca. So with all of this doom and gloom, I'm sorry to start off with that, but that's the scenario we're at today. We're in today. How do we know these salmon and steelhead will come back? I think those of us who have studied salmon life history, diversity, and evolution are always impressed by their resilience. These fish are amazing. Over millions of years, Pacific salmon as a whole have undergone massive geologic events. They've endured, I think, 4 glacial cycles, floods and major changes in the ocean, including a period when the ocean was about 115 meters below the current levels. So imagine what a change in environment and how stressful that was for them. But they've endured that, and it is that dynamic landscape and the modern landscape they face today with fires and floods and debris flows and landscapes that has actually shaped their modern diversity and resilience. So we're talking here about their ability to express various life histories, where you have some fish of different ages in different parts of the habitat. So in the very headwaters, in the mainstem Salmon River and the mainstem Snake River, in the ocean, returning all at different times. And that complexity of different fish in different times adds a tremendous ecological buffer in the face of change. And so they've always been able to deal with all of this until fairly recently. Something else that is important to be aware of is just, and I'm just giving one example here, but the breadth and depth of comprehensive science and reviews that have gone into this issue. This is an example from the comparative survival study, which involves various tribes, the Fish and Wildlife Service, and biologists from the states of Idaho and Oregon. It was initiated in 1996 as a long-term study to provide consistent data and analyses around monitoring survival of fish in relation to their passage history. So survival of the smolts as they move out of the system, and then returns of the adults as they come back in. It's collaborative, transparent, adaptively managed, and reviewed. As Rick said, he's been on many of these types of boards, but reviewed by multiple science advisory boards. They put out a really comprehensive report every year, and their most recent report suggests that breach and maximum spill at the lower Columbia dams could increase the SARs by up to 4 times. So there's a lot of promise in this management action. And ultimately, the snake is their best shot. You must wonder why all this talk about the snake, and this is why. You can see in this map in the dark green the amount of protected areas in the snake, and the Selway Bitterroot Wilderness and the Frank Church River of No Return Wilderness and all of these other wilderness areas, plus the light green federal and state protected lands. So this is really the bullseye for high quality protected lands across the West. And when you roll it all up and compare across the entire lower 48, the snake represents about 20% of the accessible stream habitat across the West Coast salmon in the lower 48, but 50% of the current cold water habitat. And by 2080, that's predicted to be 65%. So the importance of this cold water habitat will only increase. And west-wide, it also represents 40% of the public lands with wilderness qualities. So that's why overall restoring the Snake River will vastly improve the SARs, that key metric of management status and recovery. It will enable these salmon and steelhead to be resilient to climate change. And it will also, as we can discuss, unlock the power of all of the habitat restoration work and the other actions that have been done today. And it's why, we really feel like the preponderance of science very much shows that it is the restoration of these migratory corridors that's the linchpin for restoring salmon.
What we've seen, as Helen has pointed out, is the trajectory of the Snake Basin being the most productive and successful of all of the basins of the Columbia for wild salmon and steelhead, primarily because of an excellent migration route and high quality headwater habitat becoming the weakest. This weakest basin now, the Snake, is actually the linchpin of saving salmon in the Columbia as a whole. Because if we could restore the migration corridor and return those fish to the productivity that they had even in the 1960s, it would be a core source population of high Rocky Mountain, cold water, well-protected, pristine habitat, when a lot of the low elevation tributaries of the Columbia are going to lose their salmon, or they're going to be significantly weakened because of the rate at which climate change is happening.
The whole central Idaho area is Helen noted in the Frank Church Wilderness area and other areas, but they're very high. They're high elevation, typically 5,000-6,000 feet and up. And so Dan Isaacs and some of the other guys at the Rocky Mountain Research Station in the last couple of years have done a really nice series of papers on climate change, and they've identified that area as the climate shield for a lot of salmon biodiversity. And so that makes that area even more important, particularly as we see the effects of global warming. The Chinook and the steelhead that are up in the Snake Basin, even though there are hatchery programs on many of them, they're all local indigenous stocks, even where hatchery fish have been derived from them. So they're the native genotypes that are adapted to those high elevation habitats and that long migration. And if we lose them, we're not going to be able to replace them by introducing other fish, because the migration, their whole life history and migration pattern is tuned to that long migration, those high elevation natal habitats. So these fish in Idaho are irreplaceable.
We have spent billions figuring out how sure we are that there's a problem and it's drastic and it's headed toward extinction, to the point where we're now at a historical crossroads. We have no more lead time. These fish are rapidly approaching extinction. And if we don't do something dramatically to improve the migration corridor, all of our research shows there is no other way. There is no other solution. No techno fix is going to get us out of this. No screening or barging or piping or ditching is going to get us out of this. The only way we're going to get out of this is to have the snake be a centerpiece of a more natural ecosystem than we have right now. And we haven't much time to pursue other alternatives. We've spent 50 years pursuing every reasonably feasible alternative, and we're left with two big solutions. One of them is to restore the migration corridor in the Snake. The second one is to spill at the lower 4 dams and explore cooling the Snake down with stored water. If you look at the best science that exists right now, those decisions appear to be feasible, doable, successful, and any alternative to those is going to lead to extinction and abrogation of the treaty.
What Jim said is about certainty and surety. What has happened over the last 30 years, 20 years since we did some of our key writings, is that the data have just become stronger and stronger and stronger. And it's really no longer a kind of, well, it might be, or it's probable, it's certain. So we really know the data are overwhelmingly clear as to where we're headed if we don't take significant action. It was encouraging to see Governor Inslee and Senator Murray identify a study specific to taking the Snake River dams out and a relatively short timeline for the study. In the past, studies has been kind of a catchphrase for we'll table it. This one, I'm always, I like to assume positively rather than negatively. So I'm assuming that this is actually what's going to happen, is that it's going to be a legitimate study and it'll come out and give us a direction. If the direction it gives is to leave them in place, then we're probably done.
The only thing that's going to move these politicians is a stronger and stronger voice from the public. We need to make it harder for them to avoid making the decision than to make the decision. We still have time. We're still capable of doing that. The test is before us. We spent 40 years getting the science in order so that we're very, very certain what the problem is. And we're very, very certain what the solution is. We're pretty darn certain there's no other magic bullet solution other than the one we're proposing. And also, what we've lost is the lead time. So now we don't have any more lead time to mess around. We either make a decision to save these fish and honor these treaties, or we make a decision to delay, which is the same as making a decision to let them go. Our children are going to judge us one way or the other. I prefer to have them judge us with success and with courage and with resilience and a commitment to this ecosystem and this culture and this region we live in, rather than taking the kids to the museums to see the old pictures and the extinction vortex moves up to British Columbia or Alaska. I think we still have time. Now's a critical time. Think of us at the crossroads as a people. If we delay any longer, we're essentially making a decision to accept abrogation of the tribal treaties, and we're essentially making a decision to accept extinction.
Thank you, Helen and Rick and Jim, for sharing your time with us this evening and your expertise. It's a really powerful presentation and comments and discussion, so thank you. If you'd like to see the full presentation as part of our webinar series from this fall, please visit our website at www.wildsalmon.org. As the scientists have made clear, we're at a crossroads. We're now in a position where we have to act or risk losing these irreplaceable species and really emblematic species for our region. And that's where all of us have a role to play. The good news is we've got emerging political leadership in the Pacific Northwest and in Washington, D.C. And they need to hear from you as they engage in this issue and think about what they're going to do moving forward. They're hearing from lots of people from all different kinds of perspectives. So it's really important for salmon advocates, orca advocates, fishing advocates, to make sure their voices are part of the conversation and that we're speaking loudly and clearly that we support the leadership that's emerging and we also support a comprehensive solution for the Pacific Northwest that restores the lower Snake River and invests in communities and infrastructure. It's a huge opportunity for us, but we don't have much time. So thanks again for watching. Please reach out if you have questions or comments or want to get more involved. And please contact your public officials and ask for their leadership. Thank you.